Hello, everybody, and welcome back to the 2022 AI4 Technical Summit. Our next panel discussion is going to be titled Leading Your Data Teams to Success, Methods and Tools, featuring some incredibly intelligent folks who also happen to be devilishly handsome. Our moderator is going to be Barak Ben Ephraim from CVS Aetna, and our panelists will be Sudeep George from iMerit and Thomas Kriwox from Veritone. Let's get a big round of applause for your panelists as they take the stage.
Thank you, Martin, for welcoming us. And thank you, panelists, for joining and taking the time to be here. I would like to definitely introduce our first question to everyone. The first question is building a world-class machine learning ops platform a communicated focus for your organization? As a follow-up, we'll ask how long has that been an express goal within your company? And if Sudeep, if you don't mind, we're gonna start with you. If you can just tell us how it is in your company.
Absolutely. So yes, it is a committed focus. It's been a focus for the last couple of years. We essentially help our customers in productionizing their AI systems. And what we've been seeing over the last few years is many of these companies actually going live with their AI systems. And as part of that journey, there is this combination of working with a lot of data, experimenting with a lot of ML models. And as part of what we do, security and compliance are very important aspects of our ML journey. So the only way that all of these can work together if we have a very strong and focused MLOps pipeline. So that's been one of the core areas that's being developed within the company. And it's also something that we offer to our customers as products and services, and they leverage it to build their own ML models.
Nice. And Sudeep, as a small follow-up question, do you guys do that currently in the cloud, or you have a proprietary system?
So we've moved to the cloud pretty much at the beginning, given the volume of data that we work with, and the fact that we work with a variety of customers who actually work across the entire spectrum of AI systems. It's very important that we have a cloud-based infrastructure that can actually be leveraged for a lot of the ML development, data management, and model serving and maintenance. So it's all been cloud. We do have a couple of proprietary systems that we leverage, but they work on specific components of the MLOps pipeline, and we use it, for a variety of customer-specific reasons.
Got it. Thank you for sharing, Sudeep. Tom, if you don't mind sharing a little bit how things are at your company.
Yeah, so similar to the previous response, it is absolutely a committed focus for us, and it has been for the 7+ years that we've been in business. And really the way it looks for us is the same challenges that we're experiencing when designing, building, deploying, testing, and training models. Those are the same insights and experiences that have really led to the platform features and applications that we support. So it also is part and parcel of what drives our roadmap. So we have tools like our developer app, and those tools enable organizations to onboard, manage, update, and focus on sort of changing the being able to onboard new bespoke models. The nice thing there is we also facilitate being able to make changes across platform resources without having to focus on the actual changing the model. So we're scaling, auto scaling up and down based upon your model's needs and requirements as you're moving along. Another aspect of what we're doing to sort of simplify the whole MLOps process is the platform is standardizing around common IO interfaces. So basically, the results that you have from your model are in a shared structure that can be used throughout the platform. And I think what I focused on in the first part, which is the tools and the applications that we've built and made available to customers. These are the same tools and applications that we're leveraging internally to build and bring models into our platform. So as well as build out point solutions as you know, our direct go-to-market sort of strategies. So in essence, and what I'm sort of saying in summary is we eat our own dog food.
That's great. And Tom, how long ago have you guys moved to the cloud, if I may ask?
Yeah, so you know, I don't want to just, that's not the only place that we sort of, you know, we also work in a hybrid, you know, sort of deployment environment, as well as a completely network isolated, you know, based on some of our customer constraints, working in, you know, government and things, you know, serving municipalities where there's, you know, the sort of sensitive operation and the inability to sort of share that stuff over the web. We sort of, our model, our platform sort of scales across those different environments. So it's sort of a la carte in terms of how you, you know, what your deployment model looks like. So it's definitely not that one size sort of fits all deployment. But yeah, for the most of our customers, the SaaS, you know, cloud-based hosted platform is really the, you know, the play.
Fantastic. Okay, thank you so much. I will just share a few words of how it is at CVS Aetna and my company. It looks like we're a bit behind the curve from what I'm hearing from others. So we are actually in the midst of migrating into the cloud. It's been a great push this year and probably will go into the next as well, because prior to that, we've been kind of in-house. And, you know, I can't even begin to describe how many challenges we've experienced with deploying machine learning models, because we have two disparate teams, like a data science team and a data engineering team. And unfortunately, sometimes they don't work in tandem, and you kind of, or, you know, once our data science teams build a model, they have to, you know, speak to data engineers to have to actually implement that model. And many a times there's the challenge of many kind of challenges. One of them, for example, well, data engineers are only using Python 3.62, and now like the latest Python that this model was written is like in 3.68, like in a much later version, and you don't really have some of the functionality in the prior, you know, Python that you know, data engineers are in. So now that's kind of some of the challenges that we have had. So we're actually made a great push this year to move into the cloud and are in the process of doing that. And to reap, of course, the many benefits that Tom and Sudeep have already mentioned, the basically, obviously, the scalability, the speed, that also has been quite a bit of a challenge for us internally, because we have one too many users trying to use our resources, and it just sometimes bogs down the system and it makes it much slower than it should be. So yeah, we're looking forward to that migration this year. All right, thank you, gentlemen.
I wanted to add on real quick, because one thing, you know, I think one thing that I saw at a previous company, not Veritone, where we were actually trying to, you know, sort of build out the discipline of MLOps, you just hit on something that I think like really impeded our ability to be able to deliver, and that was literally the compartmentalization, the silo effect of, you know, data scientists, data engineering, you know, developer operations, like all of those things being super siloed, and things like, you know, version of language and just like the concepts and sort of the processes that don't necessarily translate or aren't natively understood. There's very few, you know, singular people that sort of are that unicorn where they're awesome at, you know, doing the data engineering, but also super good data scientists, and then have the development skills, you know, to really fully deploy and get models into production. So that person, and if they do exist, please reach out to me. You just brought up a really big challenge and for our organizations, and sort of, you know, getting to a place where they can leverage and use MLOps.
For sure. Yeah, by the way, this is definitely not common only to our organizations, but it's in many other organizations as well. And yeah, hopefully the cloud-based system will resolve many of those challenges. Absolutely. Yeah. Okay, Martin, let's move on to our next question, please. So next question, tell me about a time when you noticed the difficulty in building an end-to-end process for productionizing machine learning models. And Tom, this time around, we're going to start with you. as our first speaker, if you don't mind.
Yeah. So we were solving for. I'm gonna redact the name of the actual organization, but I'll describe it as a North American, border organization that that basically services as a point of disembarkment as well as folks coming in. And what they're looking for was a really specific or particular model where they would detect a very particular object. Again, I'm speaking in really vague terms, and the reason besides the fact that some of the information just can't be shared due to the nature of the engagement, is the fact that finding basically data to actually build a model and train a model is extremely challenging when it's so bespoke, when it's so novel in terms of what they want the output from the model to sort of be, that it really creates a lot of challenges in getting something built, tested, trained, and productionalized. So really what we had to do is work through on how to get that data and how to build out a model that was reliable, that could yield the results that the customer was looking for. I could probably come up with a half dozen examples where this is sort of the same scenario. Data is king. It's getting the right data, getting your model to train against that data, and then you get into the whole MLOps, getting it out and deployed and into production. So yeah, I think for us it's it's the challenges are around building and getting the model, as well as sourcing the data in order to properly ensure that the model is doing what it needs to do.
I appreciate that, Tom, for sharing. And Tom, in general, if you were to quantify the deployment, the full life cycle of deployment of a model into production, how long on average would you say that takes? Was it a half a year? Is it 4 months? Is it a year? How would you quantify that?
We in these engagements, we don't get the luxury of half a year, and again, we have a lot of tools at our disposal, the ones that we make available to our customers. But in that particular engagement, the discussion and lead up to understand the requirements, notwithstanding that, because a lot of it is in those engagements, you really need to understand from subject matter experts the business case that you're trying to solve. That's first and foremost. That informs the sort of data that you're going to have to retrieve, as well as the sort of model that you're going to have to build out. So if you want to ignore that front part of it as a product person, I definitely don't ignore that, because that's sort of key to what I do. The whole iteration and building out the model, that takes months. It really does, even with a dedicated team in a bespoke sort of way. A shameless plug here, we do have tools. We have hundreds of cognitive capabilities that are already certified and on board within the Veritone platform, and we have low code sort of designer tools that allow you to build out workflows, so you can test some concepts, especially as you're iterating through maybe some of the like, is the data correct? Do I have the correct business case that I'm trying to solve for? There's some things that you can do in the interim to sort of shrink down that time and make it a little bit easier to go to market. And we, like I said, I'm not just using it as a shameless plug. We use those tools internally to sort of understand, hey, where are we at, and where do we want to go with this? It helps inform what we're going to do when we go to productionalize these models. So yeah, but it still takes time.
Takes months, I hear. Thank you, Tom. All right, we're going to move on to our next presenter, Sudeep. Sudeep, how is it in your company?
Yeah, so before getting into the answer, I just want to build upon what Tom said, and I wholeheartedly agree that it's all about the data now. It's data-centric AI, and we've seen this across all of our customers, and we work with multiple domains, different customers in a specific domain. And in all the cases, it's always the data that makes the difference. That being said, it's not about quantity of data, it's the quality of data, right? And making sure that you manage that quality of data is key to success. Coming back to the question, an example of where we've had issues, I would like to go to another end of the spectrum where we've been seeing a lot of problems with the training serving skew. So just to explain that, it's the difference in performance of an ML model while it is being trained and its actual performance in the field. And in many a case, turns out that the way the model performed in your lab, in your training, doesn't really translate into how it's performing into the real world. A couple of reasons that contribute to this issue. One, you could be training on incorrect data, and that happens a lot more than it is publicized. So I always keep saying that ML ops and ML in general is just like 20% of ML algorithms and deep learning, and it's 80% of engineering, right? And maintainability, reliability are very key aspects to it. So you could train on wrong data, or your data has actually changed between the time you trained on it and the time that you're actually using it in the field. A very good example could be, let's say, pre-COVID and post-COVID, multiple examples where folks have trained their models for a lot of retail goods, but then turns out post-COVID, the requirements across the globe from consumers is very different. So many of these models fail. So kind of keeping track of these issues and making sure that you're able to quickly react to them is one of the tougher lessons that we have learned along this whole process. And that's where, you use a set of tools, use a lot of performance metrics to keep ensuring that the model actually performs the way it was designed to in the field.
No, thank you. Model generalization is key and critical, because you're absolutely right. It can perform beautifully in dark mode, and but not generalized to the real life situation, which everyone cares to see, of course. Absolutely.
Many a long night have been spent in that process.
Absolutely, yeah. No, thank you, Steve. That's a great point. I will just round it off to kind of share a little bit about CVS Aetna. I was kind of almost hands-on involved with my team in building a length of stay model. Just a few words, I can actually share a little bit more about what the model is. It's basically predicting when a patient comes into the hospital, with a certain diagnosis, certain issues, given the facility where he's at, and his disease history of who he is, of who that person is, can we predict how long this patient will stay at the hospital? So that was the task at hand. And I'm just gonna, of course, combine and summarize a few challenges that you guys already have definitely shared with us. So one of the key challenges was the data and getting the data. And funny enough, in such an organization as CVS and Aetna, you would have hoped that the data would be clear and people would know where it is. That's not the case. We actually have only few veterans, quote unquote, who've been with a company like for 15, 20 years, to actually know different tables and what they have and what they don't have, and all the nuances and challenges with that data in those tables, which we kind of ping and ask, because really there's no internal, quote unquote, data dictionary or something that's more refined, like, oh, how do you join these two tables? What's the key that will join them, for example? Because many times they're not joined by a simple key. Sometimes it's a complicated key, like of 2 or 3 different independent variables. So it's very important knowledge, but which is not explicit. It's embedded into the minds of these few veterans at our company. So just getting the data pulled together for this effort was quite a bit of an effort. I had a team that was doing it. Took us 2 or 3 months to do it. And the funny part is that many times we were said, oh, please reuse the code from that team over there. They already had done it, a year ago, for example. So, one of the challenges that I find with that approach is that, I like to trust, but I like also to verify. And one of the things that we noticed that some of that code was not correct or had to be updated. To your point, Sudeep, there was definitely challenges with that. Some of the things became outdated or things have changed over time. Now that was, of course, data gathering. The other challenge that occurred was one of the key processes which we were building this model for actually changed in the real world. So we had to really quickly pivot and adjust our model to accommodate that. So that's another interesting thing that you kind of run into when you're building a sophisticated model. Sometimes the real process in the world changes and you have to modify the model to account for that. So that's another challenge that happened. And last piece that I think Tom definitely touched upon is, once we have the model built and it performs quite nicely, let's say in a dark mode, is getting it productionized with the data engineering team. So that's an effort in and of itself. Took us about 3 to 4 months to get it productionized. Why? Because it almost kind of felt like starting from scratch, because the data engineering team had to look at all the functions that we had written. They had to replicate every table that we had pre-built. Many of the folks on their team are very new, not very familiar with these tables, made a lot of errors, and we literally had to check on them day in, day out. Why is this column not lining up? What's going on over here? Oh, they used that table, which was outdated, for example. So a lot of challenges like that, not to mention the few challenges that I already have mentioned in the first question, such as they're only allowed to use this Python version, which is like maybe 6 months behind, and we use the latest one with the latest functionality. So that there was definitely a disconnect there. And the last challenge that I'll just mention very quickly is that some of the parts of our model have already been used in other models, and they told us, that table was already used, and the variables that were called by previous models is, let's say, X, Y, and Z, and you actually chose different name variables for your model. You can't do that. We want to reuse those old other variables. So we had to like cosmetically change those variables already what already has been used to kind of have a standardized production block for that model that was kind of consistent throughout the company. So that was something else that was a bit of a challenge, something that we were uninformed when we were just building the model. So that another challenge that happened. So anyways, in the whole sum of things, takes about 6 months to a year to get a robust, good model out. Definitely not an endeavor for a month or so. So that's for sure. But thank you, gentlemen, for sharing those interesting insights. And we're ready to move to the next question. What are the key changes you're seeing on the back end of your organization to enable getting more and higher quality models into production? Is it involve more people, more qualified people, data projects, vendor procurement? What are you guys doing to enhance that process? And we're going to start with Sudeep here.
Sure. So it's a combination of all of these, ways of kind of improving the performance. But I think the most significant improvement is in actually the tools that are being used within the MLOps process, right? So when we started off perhaps a couple of years back, it started off with Python libraries that were being used within your own codes, and you were kind of handcrafting a lot of the MLOps capabilities. But today you have full-fledged tools which are available and which provide great features, and in certain cases make or break the kind of quality metrics you're trying to achieve. Just to dwell on a couple of them, one of them that has really stood out for me has been the way that you handle edge cases. It's a function of how data is handled, but very specifically focusing on edge case management. And that's something that we have developed internally, but we have also seen a lot of our customers coming back and saying that, hey, we want to have this capability, because you know what, most of these customers are now pushing their products out into the market, they're going live, and they know that the difference between the training that they have done within their own labs and going live is their ability to handle these edge cases. So managing these edge cases becomes very important. And in certain cases, depending on the kind of domain that they're coming from, it's not just a question of training on a lot of data. You have to train specifically on those gaps within your data while you're solving for edge cases. And many of these tools provide insights which allow you to focus on those gaps and kind of build improve the model to kind of handle those scenarios in the real world. So that's one factor. The second aspect is about monitoring tools. I think there's an increased focus on how well can you monitor your ML ops pipeline, and what are the facets that you can leverage to kind of improve performance. And then going back again to some of the options that were presented, yes, there's an increased need for domain experts to come in. And this goes back to quality data, because traditionally it's been about just getting data and training your models, but you need those domain experts. And I see that in fields like medical imaging, where you really need people who come in who know exactly what they're doing, and they know exactly what data makes the difference from the ML model performance. So you need these domain experts coming in, and the domain experts with the tools, I think are making, are improving the quality of the models that are coming out.
Those are great points, Sudeep. Thank you. I will just have one other follow-up questions for you quickly in terms of your edge cases. Quick question to you. It's one thing to kind of forecast all the possible edge cases that you can ever encounter, but I'm sure there are times where, you kind of tell me, Baruch, sometimes, we didn't foresee this edge case ever occurring, but you actually see it in the real world data. Does that happen with your, in your organization as well?
Absolutely. And I think being able to isolate and narrow down to those edge cases, which possibly didn't ever come within the training guidelines, is key to kind of rapidly solving them, right? And there are many ways of doing it, and not every method is foolproof. But I think kind of having an ability to move through your data and understand where the failure occurred and what was the data looking like at that specific time, and also getting people who specialize, in some facet. If it's somebody who's, if you take the case of autonomous vehicles, folks who understand fleet ops, who understand, how mapping has to be done correctly, do come in and they provide insights saying, hey, you know what, I have this domain experience, and you leveraging that domain experience, you can kind of narrow down on what are those cases you have to solve.
No, thank you, Sudeep. That's great. Tom, let's hear some of the things that you guys are doing to improve your operation.
Yeah. This is going to be a little repetitive to some of the things I mentioned earlier, but the quality and quantity of in sourcing of the proper data sets is again, it's like the most important aspect to ensure that the models are properly trained. And it starts and stops with their garbage in, garbage out sort of mentality. For us as well, it's quantitatively, looking at and measuring the accuracy and performance of the model, whether it be versus other models that we already have that are doing a similar function, or the same model over time, so that we can account for drift and sort of indicate that it's time to source new data sets and retrain, because the model's not where it needs to be, and some of that just as we talked about could be due to edge cases that weren't properly identified. But it really all comes down to making sure you're sourcing the proper data sets, and the quality of those data sets is there. On the measuring side of things, again, I'm going to shamelessly plug, we have a product that we use internally as well as our customers use, called Benchmark. And basically what this allows for our customers to do is to test a model's accuracy and performance. And again, you can test it versus another model, either that you've already onboarded, or you can test it against itself as time has gone on, to test for things like drift. Again, these are applications and tools that were created because we had a need internally. There wasn't really anything out there that fit the bill. And so we've built these tools and productized them, and then made them available for our customers. But yeah, back to the original point, quality and quantity of proper data sets.
No, of course, can't stress that enough. Absolutely.
Yeah,
I will share a little bit insights in what Stevie said now, of course, echoing many of the sentiments that you guys already presented. First and foremost, I will definitely say that we are in the process of building intelligence monitoring, to Sudeep's point, kind of monitoring the performance of the many, many models, not just one model, because exactly to your guys' point, we need to know when we actually should retrain the model, because it works up until a point, and then a pandemic hits, and then the model can go out the window. It might be terrible. You can't just like haphazardly just use the same old model that maybe worked a year or two ago. You definitely have to keep the pulse on the model. So we're definitely actively building that dashboard. It's not so simple, by the way, because that intelligence monitoring is a very complicated task, because you can have an outlier day. What really is a normal band of performance? Kind of specifying that range is also an interesting challenge. But at least we're in those stages of monitoring, at least the accuracy, the recall, and things like that. So that's good. Of course, I'm sure in many times you can't even measure the accuracy of the model, because the real results will only be available a few months down the line. So that's another key challenge with that. But definitely the concept is there. And one other small item that I just want to mention that we're doing in our organization, aside from also getting more SMEs and just the sheer number of folks who will do the work, our team burgeoned, I think, by 300% over the last 3 years. So we're growing like crazy. We're gonna need to convince the C-level executives that data science is great and amazing. So they're definitely ready to hire. It's hard to hire quality these days. But one of the incredible things that we're building as an organization is an incredible model called Castle, which is basically a supervised time series deep learning model. And what is it attempting to do? It's basically pulling all the data from many other groups into this one ginormous data set. Like imagine, you're pulling the demographics, the disease history of folks, the hospital history, facility history. You have pretty much everything kind of in one universe, and leveraging, and by the way, and also using time. So meaning to say, I'm sure many times there's events that happen and and they change. Like for example, when was your scheduled appointment to see the doctor? And first time, it might have been rescheduled 3 times before the patient actually gets into the hospital, for example. And most tables, traditionally, the way they're done, you only see, well, finally the patient appeared in the hospital on this date, but you don't see the complex history behind it. So we're kind of leveraging that complex history that is kind of layered back in the history of our tables, to kind of leverage that to create a much more robust and powerful model. We already have done some pilot tests on our previous models that we built through traditional machine learning techniques, like boosting models, regression models, et cetera. With this new time, it's like a 3-dimensional component now of this time a view of things, and that model is proving to give a tremendous lift to our quote unquote vanilla flavored models, upwards sometimes 200% increase in the lift. So it's been very successful. Obviously we have to use, it's very computation heavy modeling. It basically eliminates one of the what I call quote unquote creative elements of data science, which is feature engineering. It basically does the brute force, I don't say fully brute force, but combinatorially complex feature engineering by itself, doing like millions and billions of those new features and testing them. So that's something that we're kind of building out. It requires a very special node of like computing power. So we're gonna kind of setting that up in our organization as we speak. It's obviously in the infancy phases, but that's something else that we're trying to implement. It's the new trend right now. All right, guys, thank you. Let's move on to our next question, Martin, if you will. Now we're going to ask a very interesting question. If you were to start building a machine learning operation platform from scratch, what would be your key focuses? Now that you kind of seen the process of how it unfolds, if you were to redo it, how would you do it? And we're going to start with Tom on this one.
Yeah, I'm gonna stay on that consistent line of shameless plugging, but I'd buy Ai4, our flagship product, and the reason for that is because of a lot of the things that we just have talked about throughout this, and it's focusing on your production platform to make it easy to retrieve data from production, train models, and push them into production with the key criteria on whether or not that model is working well or working not. So building that feedback loop. As I mentioned, some of the the challenges that we've experienced internally from the MLOps perspective are the same challenges that are driving the roadmap, and we're helping to solve those same problems for our customers. So, yeah, I mean, this is where MLOps is going. It's going to a platform sort of perspective. It's becoming productized, and so for me, starting out. Rather than trying to scratch together and build this, ad hoc with what we know are these discrete functions that are traditionally siloed, I'm going to look for ways to accelerate, the process and make sure that that's something that I can get off the ground and operational.
Got it. Fantastic. Thank you, Tom. Sudeep, do you want to chime in on how you would envision if you were to build it from scratch?
Okay, so I would focus a lot on making sure that you have a robust feature store. I have seen that literally being the game changer for a lot of the ML development processes and workflows that we've been involved with. It's very important to use a feature store to kind of extract the right features, because at the end of the day, it is those features that make a difference in terms of the model performance. So extracting the right features, training your models, and you would have gazillion models being trained. So making sure that they're being trained on the right set of features, that maintainability needs to be built into the feature store. And that is another important component of the feature store. Feature stores also help in serving these features to the models when they go live, and that is very important because that is what enables the model to understand its performance in the real world. And by tracking the metrics associated with a particular algorithm or with a particular product as it performs in the real world, you get to understand whether your model is actually doing its job or if it's being affected by some sort of drift. And once you understand that, then kind of monitoring all the parameters associated with those features really helps you in accelerating the process of making sure that your models are always relevant. So I would really focus, and this is based on a lot of hard-won battles, that getting this right is very important, and with this in place, it really accelerates the whole process.
Great, that's great points, Sudeep. Thank you. Yeah, for my end, I just want to add, just having a one unified ecosystem and obviously being in the cloud to facilitate the speed, that for sure would optimize the development process, because we many times find, like during the day, it takes up to 5 to 10 times longer to run even certain queries and our modeling. So there's definitely that challenge. So obviously in the cloud should be a great change. And as well as what Sudeep just mentioned, a kind of not a data, quote unquote, data dictionary, but at least making the connection between various tables in our ecosystem of data kind of be readily, how do they join? And let's say a new person comes in and they didn't know how these two tables join, for example. They need to kind of find the veteran right now. And that sometimes takes 2 or 3 days until that person responds. So kind of having more than just like a data dictionary, but some architecture which kind of informs of how various tables join, that would be very super good and useful. So that's something that I would also build into the company to help out. To round up our interesting discussion today, I want to conclude with this interesting question. How do you anticipate this machine learning operation platform to look like in 10 years? Like what do you anticipate will come in about 10 years time? And let's start with Sudeep on this one.
Sure. So I think there's going to be a very strong focus on getting good quality data, and Given the wide spectrum of data points that you can get from the real world, it'll be very important to kind of get processes as well as tools that help you understand your data better. At iMerit, for example, we make sure that we are able to provide our customers with intelligence about their data. And I think we are just at the early stages of understanding how impactful that intelligence is from with respect to AI development. So a lot of tools, a lot of processes that help accelerate your understanding of the data, making sure that you are able to get data which is free of bias, which is where you can explain what's happening within the data and how the model's performance is correlating with the data that it's receiving. I think all of these are going to be very important aspects, and there's just going to be a lot of tools and processes that actually come around this specific point and kind of mature as we grow this ecosystem.
Absolutely, yeah. The key importance of data, otherwise the house will collapse without the foundation. Absolutely,
Absolutely.
Thank you. Tom, what's your vision in 10 years? Where we're going to be?
Yeah, so first off, I agree with everything that was just said, and I think it's a key component of all of this. And where I think it's going to go is I think that MLOps will look more and more like normal development, with these things sort of built into readily available CI/CD pipelines with proper unit testing and the sorts of things that we expect today in our normal development environments. These tools and these products are being productionalized and they're out there and they're available. And organizations aren't having to piecemeal it together anymore like they were. And the information is consolidated, through a lot of different providers out there and vendors. So yeah, I think that a lot of that heavy lifting that you were having to do in the early days, geez, it wasn't probably that long ago, but the earlier days, there's a lot more solutions out there that exist and are sort of combining all of these challenges under a singular umbrella. So that's where I think we're going. It's going to look more like normal development. That's my hope too.
That's great. Yeah, hopefully we'll see that, of course, in the years to come. Yeah, I just want to share, I guess, last few concluding thoughts and comments. I guess what I see at CVS and Aetna in the next 10 years. Getting back to what Sudeep has mentioned, the importance of data and feature engineering. One of the things that I for sure foresee in the coming years is that we have many groups building many models right now from sometimes similar data and sometimes even same data. And unfortunately, as Tom has mentioned, they're very siloed right now. And they build a model with these set of features, and this another group built another feature. So it would be awesome and amazing. We have like a tool, almost like an AI tool, which says, there were previously or historically models built that utilize these particular features. Maybe you should look at them, or at least consider them in your model training, because sometimes a certain group doesn't even consider it, or it was not even aware that these features exist. So I hope that in the future, there'll be a more cross-sharing of these key features that are important. So that's one interesting development I hope to see. And the other thing that I just as a side point I already mentioned about the castle model, I think once we will have like certain predictions for other models built, kind of integrating those predictions into the big model, and hopefully leveraging those results to build new models. So that I think that will also become beneficial. So you can have the laurels of history kind of helping you out with that as you move forward. All right. Thank you, gentlemen, very much for your insights into this matter. I really appreciate your time, and I hope to meet again sometime soon. Thank you, guys.
Thank you, Baruch. Thanks, Tom.
And we get a round of applause for our wonderful, wonderful panelists. Thank you all so much for coming in. Thanks for sharing your knowledge and your time. And thank you to the audience for being here to take it all in. Please remember to check out our other artificial intelligence exhibits that we have going on at the summit, and to check out the other sessions that we have going on. Thank you so much to our panel. Thank you so much to our audience. Take care.